Jaden. Good morning, everybody.
Good morning, sir.
All right, good. So I take it everybody can see the screen and stuff. All right, so let's get straight into it. So as I told you, today's session, we are revising some more of the material that we have covered since September, and we'll do that from this past paper, January 2018. So we're going to do the questions on this paper from the topics that we have already covered and from some of the topics that will be taught by example. All right, like the question once. So we're going to start with number one. Right here. And this is a use your calculator question. So let me bring up the calculator. And as usual, what we want to do is enter this information exactly as it appears there in the calculator. And we have to give our answer as a fraction in lowest form. And that's why you must get one of those calculators. I keep repeating myself. You must get one of those calculators where you can type this in exactly as it appears there. All right, so I'm going to do that on this calculator on the screen. So starting out with a mixed number, 5.5. We're dividing another mixed number, 3 2/3. And then we're adding another mixed number, 1 4/5. And this is 3.3 as a decimal. You can see it as a decimal, which is right as a fraction, sorry. This is that one. 33/10, or as a mixed number, it will be 3 3/10. So the answer here is 33/10, or 3 3/10. All right, so that is that. All right, but we're good at that. Nice and easy. They also want us to do this one, and they want us to give the exact value. So again, we're going to put it in the calculator. And the dog has been quiet all morning until I have started to have class. So I'm going to type that in the calculator again, this one. which is 165 times, it is 0.38 squared, and that is 23.826. That's 23.826. Just making sure that what we have here is the same thing that we have typed in the calculator. All right, and that is that. Then we come to this part, which is the right answer that we got in part 2, which is the 23.826. We have to write that correct to 2 decimal places. So I want to correct this to 2 decimal places. So let me write it again here, just to show the working. 23.826. I'm going to correct it to 2 decimal places and put the value here. To 2 decimal places, the second decimal place that we are correcting is this one. This 2, that's the second decimal place. We're using this 6 to correct it, because this 6 is a value, and the value 5 or more will increase this one, and because this is 6, it will increase this 2 to 3. That's what the correction is done. And so the result then is 23.83 to 2 decimal places. Then they want to correct the 3 significant figures. So let me write it again to show the process. 23.826. We want to correct it to 3 significant figures. Now you start counting significant figures from the left to the right. The first non-zero value is your first significant figure. So this is the first significant figure. This is the second one, and this is the third one. So we're really correcting this place. Remember, when you make your correction, the size of the number must not change. This number is in the 20s. So your answer still must be in the 20s. It cannot go in the 10s. All right, this number is in the 10s then. Let's put it that way. All right, it cannot go into the 10s. It cannot go into the 100s. The size of the number must stay the same when you do the correction. Any correction you do, the size of the number cannot change. So when you be using this 2 to correct the 8, 2 cannot correct 8 because 2 is a number less than 5. And so this 8 remains as it is. And the values afterwards become 0, but because they are after decimal point, we don't need to show them because they are all after decimal point. So technically, you would write 23.8. Then replace these numbers with zeros. But because these zeros fall after decimal point and they're the last set of zeros, they don't change the value of the number, so we don't need to show them. And basically, that is it. 3 significant figures. And also, when a question asks you for 3 significant figures, your answer will have 3 significant figures this way, which is what that is. Then this one wants us to go to the nearest whole number, the nearest whole number. So I'm going to write it again, 23.826. The whole number is the number before the decimal point. The number before the decimal point. All of this becomes your whole number. Right? And you want to correct that whole number using this 8. So this 8 is going to correct that 23. It's going to correct the 23. So because it's an 8, a value more than 1, it's going to increase it. It's going to increase the 23 to 24. So to the nearest whole number, it becomes equal to 24. And if you look at all these answers, they are of the same magnitude. They have the same size, really. Right? They are really about the same size. There's just different ways of correcting this value, depending on what you want to use the value for, depending on the level of accuracy that you want in the values. But those are your answers. But okay with that? Very good?
Yes, sir.
Yes, sir.
Good. So let me take this off now. All right, so continuing down here to part B. This question says, Mr. Adams invested $5,000 at a credit union and received 5,810, inclusive of simple interest. The keyword here now is simple interest. So it's a simple interest arrangement after 3 years. So once you're doing a simple interest question, your simple interest formula becomes relevant. Simple interest formula, I'm going to write it up here. It is I equals PRT divided by 100. The principal is your initial amount invested. The R is your rate of interest. And the T is your time in years. The rate of interest is a per annum rate of interest. And for example, if it is 5%, it means that the R is equal to 5, because the percentage part of it is taken care of by the 100 under here. All right, and remember now the T has to be time in years. So for example, if they give you 6 months, it's 6 months, 6 months is just half year. So the T will be equal to a half. If it is 6 months, time period of 6 months. If it is, for example, 18 months, if it's for 18 months, then the time would be 1.5. It's like you divide 18 by 12 to get the years. So if it's 18 months is the period, then the T will be equal to 1.5. If it's 24 months, if they give it a time in months, 24 months, then the T will be 2, because there are 2 years in 24 months. So we'll be careful. That's why a lot of people make mistakes all the time. Mute your mic, please. Mute your mic. So we're going to apply this formula. So it's a matter of seeing which of these values they want based on the information. Some questions will ask for the interest. Some questions will ask for the principal. Some questions will ask for the rate. Some questions will ask for the time. You just transpose depending on what you want to find. So let's see what they give us in this question. So based on the fact that the amount received was 5,810 after investing 5,000, it is clear that the interest amount is 5,810 minus 5,000, which is $810. And I think they asked that in the first question here. What is the interest? The simple interest is simply the total amount at the end minus the amount invested, which is 5,000. They're trying to deal with the dog for me, guys, so just be patient with me a little bit. This becomes 810. So it is like we know this value is 810. All right, we know that value is 810. If we were to pick out some of the other information from here, this amount is your principal, the amount that was invested. So that is your P. This is your time in years, so that is your T. This becomes your T. I will just calculate it from this information that the interest is $810. Right? So the only information, if you notice from this formula, that we don't have is the rate. So the only thing they can ask us for now is the rate of interest, which is what they did right here. They're asking us to calculate the annual interest rate. And the interest rate in this formula is for an annual interest rate, because the time is in years. So we're basically trying to find R. This question is about finding R. That's what we're trying to find R. So we're going to transpose this formula to make R the subject. So to make R the subject, we are multiply away the 100. Let's do it right here. We're going to multiply away the 100. I'm trying to leave R as a subject. Right? So I'm going to multiply away the 100. So I'm going to get 100i. I'm going to then divide under the P and also divide under the T. So I'm going to divide by the principal and the time, and that's going to leave the subject as R. So once I put the values in here, I'm going to calculate the rate. This will give me the rate. So let's do the calculation here now. Let me move it to the side. So this is going to give me the rate. And so I can see that the rate is going to be 100 times the interest amount, which is the 810. I don't have to put the dollar sign. It's 810 divided by the principal, which was 5,000, multiplied by the time, which is 3. And I just need to put all of this in the calculator now, and I'll get my rate. Remember, it's a rate as a percent. So the number that I get, I'm just going to add the percentage symbol on it. All right, so I'm going to get 100. I'm going to put the fraction. I'm going to do 100 times the 810. I'm dividing back by 5,000 times 3. And so it's 5.4%. So the rate is 5.4%. The R is 5.4, but the rate is 5.4%. So this is my answer. The R is 5.4 now, but the rate is 5.4%. That is my answer. 5.4%. In the formula, the R will be 5.4, but the question asks us for the rate. And so I'm adding the percentage on it to state the rate, that this is my percentage rate of interest. But good with that? But okay with that?
Yes, sir.
All right. This question says now we have to calculate. All of this is to determine, right? We are determining, this is to determine all these things. The next thing we want to determine is the length of time. So this question is asking us for a t value, right? It is asking us for a t value. So we're now trying to find a t value. All right, so it means that we're going to have to transpose the formula to make t the subject. We now know the rate. We now know that the R is 5.4 here. So this question is asking us now for a t value, right? So determine the length of time it would take for Mr. Adams' investment to be doubled at the same rate of interest. Now, what does this mean? That the investment is doubled. Remember, his investment was 5,000. When it is doubled, it will become 10,000. When it is doubled, it has become 10,000. So when it becomes 10,000, it means that the interest now is 5,000. So when it is doubled, that is when the interest and the principal becomes equal. So we can simply say when it is doubled, the interest is now 5,000. And because the principal was 5,000, it means that the interest becomes equal to the principal. So that's all they're basically working out. They're working out what time it will take for the interest and the principal to be the same. All right. So we're going back to the original formula. Let me write it down here again. And we're trying to find a time. So the formula is that I equals PRT divided by 100. And we are trying to find the time. Trying to find the time when the interest and the principal becomes the same. All right. So we can say it like this. So we're answering this question. This question over here that we're answering is going to tell us that the interest becomes equal to the principal. So we're going to have the principal now. This becomes the principal equal to principal again times the rate times the time over 100. I'm trying to find the t. I have to work down here, guys. I don't have enough space. So I'm going to transpose everything away from the t. So the t becomes equal to, I'll multiply the 100 up here. I mean, you could work with the numbers in here. You could work with the 5,000 as the interest and the 5,000 as the principal. If you want, you could work with that. But I can also just work with the symbols, right? Because the symbols are going to cancel. All right, so the t here will become 100 times this principal, which is now the interest. The interest and now principal is now the same. That's why I put p here instead of the I. And so I'm going to put p here, divided by, and then I'm going to divide by this PR to leave t as a subject. So I'm going to divide the PR under here. Shortcut transposition, right? So this becomes PR. So you realize now that the p's cancel. This p cancels this p. And so the time really is when you divide the 100 by the rate. Simple as that. All right. So you divide the 100 by the rate. That is the time. All right. So let's put it right here. And so this becomes, the time becomes 100 over the 5.4. 100 over 5.4. But I go to that and here work it out. Let's work it out. 100 divided by 5.4. And it's 18.5 years. The length of time it would take for the investment to to be doubled in the value at the same rate. I'm going to put 19 years. I'm going to put 19 years because it's more than 18 years. I'm going to give it as 19 years. So I could write the 18.5, 18 and a half, but generally speaking, they calculate the interest at the end of the year. So I'm going to write approximately 19 years. It will take 19 years for the investment to double. Understand that, guys? What I good at that? If we wanted, as I said, we could have worked with the numbers, right? I'm going to show you quickly, right? So for this calculation, let me do it here. Let's zoom up here and do it. Let's do it in black. So for this calculation here, I could have instead worked with the numbers and put the interest as 5,000 and put the principal as 5,000, right? And you still transposing to make t the subject, right? This t. So it will be 100 times the interest again. 100 times the interest over principal times the rate equals the time. But then what would that mean is that this will be 5,000. This will be 5,000 if you're using the values. This will be 5,000. The interest will be 5,000. And the principal here also will be 5,000. If you're using the values, and they would still cancel and leave it with 100 over R. So the end result will be the same if you're using the values 5,000 and so on. Let me ask them to do something about the dog. Oh boy. All right. Let me just ask them to do something about the dog. Give me a second. All right, guys, let's continue. All right, everybody okay with this question, by the way? Just want to make sure everybody good with this. Everybody okay?
Yes, sir.
All right. All right, this question now. So we call a binary operation. It's an operation on two values, and they're defining what that operation is. The operations that we are used to normally are addition, subtraction, multiplication, and division. Those are our three normal operations. And we always do these operations on two numbers for the most part. All right. So we operate in binary numbers most of the time. Binary means two. So this is what we call a binary operation. But what they are doing, they are defining another operation that they're calling star as a combination of these. That's what it is. So this square root sign really is a form of multiplication, which could also be maybe seen as a form of division. And then this 4b is a form of multiplication. And then we also have the addition under here. So you see that this binary operation that they gave us is really just a combination of these basic operations that we normally have. So instead of going for the simple plus or the simple minus or the simple multiply or the simple divide, sometimes they define a new operation for us that they call star. This is the symbol star or asterisk. And they define it first. They tell us what it is. They tell us how it works. We already know how plus works. We already know how minus works. We already know how multiplication works. We already know how division works. And so now they are giving an operation that they call star, and they're telling us that that operation is. So if you read into it, this A star B defined as this means that you're taking the first value, number in front of the star. This is called a star or asterisk. And you're going to put under the square root sign first. You're going to square root. You put the first value here in this first place. And then the B value is coming here and be multiplied by the 4. That's how the operation works. That's it. They're defining it like that for us. And so this 1 star 2 is simply equal to, it's like the 1 is going where the A is. So I'm going to put the square root. And the 1 is where the A is. That's the first value. The number in front of the star, 1. Plus 4 times. And the second value is the B. And you go, the 2 then becomes the B, right? Where the B is right there. And so I'm going to put 2 there. And then you just work this out normally. Now this under here so becomes a 9, because this is 4 times 2 is 8. 8 and 1 is 9. This becomes the square root of 9, which then works out to a value of 3. So the answer is 3. So it means that 1 star 2 is equal to 3. 1 star 2. 1 star 2 is equal to 3. But I go to that. But okay?
Yes, sir.
Yes, sir.
Next part says we have to determine whether star, the operation denoted by star, is commutative. What does the word commutative mean? It means an operation is commutative is if when you reverse the order, the result remains the same. That's what the word commutative means. We have to know these words. So for example, addition of real numbers is commutative. Because if, for example, if I have 5 plus 4, that's addition, it is equal to 9. If I reverse the order and put instead 4 plus 9, then 4 plus 5, 4 plus 5, I'm reversing these two, 4 plus 5. The result is still 9. So this now means that addition of numbers is commutative. If I multiply them and put, if I test multiplication, and for example, write 3 times 5, that is equal to 15. If I reverse these two and put 5 times 3, it's still equal to 15. It therefore means that multiplication is also commutative. So addition is commutative, multiplication is commutative. These are operations. Addition is an operation, multiplication is an operation. They are both commutative because when you reverse the order of those operations, the result is the same. Now, an example of an operation that we know that is not commutative is subtraction. So if we go, for example, and say instead 5 minus 4, 5 minus 4 is going to give us a positive 1. But if we reverse this order and put 4 minus 5, 4 minus 5 is going to give us negative 1. See, these results are not the same. And therefore, subtraction is not commutative. Minus is not commutative. It's not commutative. It's not a commutative operation. In terms of the operations that we know, the ones that are commutative is addition and multiplication. Subtraction is not commutative. Also, division is not commutative. We can give a division example. So, for example, if I divide, for example, 9 by 3, 9 divided by 3, let me write it with the division symbol. 9 divided by 3. Let's write that better. 9 divided by 3. That is going to be equal to 3. In fact, let me use different values. I want to use different values. Let's use 8 and 2. 8 divided by 2. 8 divided by 2 is equal to 4. We all know that. But what is 2 divided by 8? 2 divided by 8 is going to give you 0.25. It's going to give you a quarter. These values are not the same. And so it proves that division is also not commutative. Not commutative. Right? Not commutative. So the operations of the 4 that we know, that we are used to, that are commutative, are the addition and the subtraction. So I was doing this to explain the word commutative, because we're not going to do this in class per se as a topic, when we do past papers and we come up on these things, I take the time to sort of explain them a little more than just do the question. But understand what does that mean here so far? But the meaning of the word commutative, we also have to deal with the word distributive, and we also have to deal with the word associative, but we deal with those in time. But let's just work with the commutative for now. Everybody okay with those? I understand what the word commutative means now? That when you reverse the order of an operation, if when you reverse the order of an operation, the result is the same, it means that that operation is commutative. If the result is different, it means that that operation is non-commutative or not commutative. So addition is commutative, multiplication is commutative, subtraction is not commutative, and division is not commutative. But good at that, just want to make sure you understand the term. Is that my explanation?
Yes. Yes, sir.
All right, good. All right, so we're going to find out now if this operation that they gave us here is commutative by reversing the order. So an easy way to do it really is to just, because they give me this value already, and we already know that 1 star 2 is equal to 3. To find out if it is commutative, it's not going to be commutative, but a quick test. You just need one example where it is not commutative, where the result is different. And so because I already know what 1 star 2 is, I'm going to reverse them and calculate 2 star 1. Because the question said justify your answer. Right? Justify your answer. So I'm going to calculate 2 star 1 and see what 2 star 1 is, because I already know what that 1 star 2 is 3. So if I'm going to calculate 2 star 1, just to see, so like I'm doing a test, I'm testing to see what 2 star 1 is, to see if it comes back to be the same value. It's going to become the square root now. This time now, the A is now 2, so this is going in front, right here. Right? The A is now 2, so I'm going to put the 2 here. Plus 4 times, and this now is a B, so the B is going here, 4 times B. And 4 times the 1 is, the B is now 1. So this becomes 4 plus 2, which is 6. So this becomes the square root of 6. This becomes the square root of 6 now, which is not 3. Square root of 6. And the square root of 6 is not 3. So we can write that it is not equal to the square root of 9 that we had up here. It's not equal, they're not giving the same value. So it means then that 2 star 1 is not equal to 1 star 2. Therefore, star is not commutative. Because when you reverse the order of the values, you're not getting the same thing. So it is not commutative. And that is it. But go to that. But okay? Students,
Yes, sir.
answer
Yes,
me,
sir.
so I can know if I need to move on. I'm expecting if somebody don't understand to say it, so I can try and explain it a little bit better if you don't understand. All right, good. All right, so let's continue. They were solving this inequality, the simple inequality. Remember, the steps in solving these simple inequalities is the same as solving this simple equation like 3 minus 2x equal 5. Same steps. Like you're trying to make x a subject. Same thing you're trying to make x a subject. The only difference and the thing that you have to remember with this, because that's an inequality, is that if you have to multiply or divide by a negative number during your process of making the x a subject, you have to remember to reverse the inequality sign. That's what this question is testing. It's testing up your knowledge of that. If you know that if you multiply an inequality or divide an inequality with a negative number, if you know that the sign has to be reversed, that is the test of this, because solving this and solving this is generally the same steps. All right, so let's go. So I'm trying to make x a subject. So like I'm transposing away everything away from the x. All right, so the first thing I want to move is this 3. That's right what I'm doing. So I'm going to subtract 3 from both sides, minus 3. See, I'm saying take the 3 over here and subtract it, make it negative. When I subtract 3 from both sides, I'm going to get that the minus 2x is left. Not 2x, minus 2x. So I'm left with negative 2x becomes greater than, it's greater than sign. And then the 5 minus 3 gives me 2. 5 minus 3 is this 2. Then to leave x as a subject now, I need to divide both sides by that negative 2. If I want to leave this as a subject, I need to divide both sides by negative 2. So now I need to divide by a negative number. Right, so let's write it. I need to divide by a negative 2. So let's write it. I'm going to divide by a negative 2. But because I'm dividing with a negative number, I have to reverse that greater than sign. I have to reverse it. You have to remember this, guys. There's going to be no hint for you anywhere in a question like this. Nothing there to help you to remember about your own head. So you absolutely must remember it, and you remember it by practicing it a lot. So it becomes like second nature to you. Once you see the inequality sign, especially these simple inequalities to solve, you have to remember that step. If you multiply or divide with a negative number, the sign has to be reversed. So let's do it now. So when I divide this side by the negative 2, they cancel and leave with just x. I'm going to get x on this side. The sign has to be reversed from a greater than to a less than. And then when I divide this 2 by negative 2, it becomes a negative 1. 2 divided by negative 2 is negative 1. So this is my solution. That's my solution. If the question wanted the solution set, you put that solution in set brackets. So let me write it out here for you. The question didn't ask for it, but sometimes they do. So let me write it out for you. So the solution set, if they wanted it, they use the word solution set here. You have to put the solution in set brackets. All right, set brackets, and then you say x is such that, and you put about the exact same thing in there. It is x less than negative 1, close your set bracket. This will be your solution set. The question should ever ask you for a solution set. This time we only wanted the solution, which is this. But if they ever said solution set, you put the same solution in set brackets. Down here now wants us to represent the information on this number line. All right, so we want to represent this solution on this number line. So the critical value is negative 1. That's where we start. That's like your boundary value. So you're going to put a circle on the negative 1 right here. So put it right here. And I'm leaving that circle unshaded because there's no equal on the inequality. It means that the negative 1 is not a part of my solution. X cannot be negative 1. So to show that x cannot be negative 1, I leave the circle on the negative 1 unshaded. And then I want values that are less than negative 1, which are over to this side. So I put the arrow pointing to the left, and then I write x is less than negative 1. If the equal was there, as I'm writing it here now, if the equal was there, then to show that the negative 1, the x can also be negative 1, then I would have to shade this circle. That will be the difference, and it will be x less than or equal to negative 1. All right, but this one is just x less than 1, less than negative 1, so that is it. All right, and that answers that part. Another question they might ask sometimes, is what is the maximum value of x if x is an integer? All right, so let's write it this way. Maximum value of integer if x is an integer. X. If x is an integer, what would be the maximum value that x can be? So the maximum value would have to be this one. Because remember, I know the x can be negative 2, negative 3, negative 4. But all the values down this way are less than this one. And so this will be the largest one it can be. It cannot be negative 1. Remember, the integers are your whole numbers, So if I were to list the integers, for example, here for you, the integers would be the set. And I'm going to put So you look at that to mean that I'm continuing from negative infinity, and I'll put a -4, then -3, then a -2. So like from -2 all the way down to negative infinity. If I were to list the values, this is the largest one in there. I cannot include the -1 because I'm saying that x has to be less than -1. So I cannot include it. So this will be the largest one. Largest. At the maximum value. That will be the largest one. Largest integer. Would be x equals -2. If they ask you for that. So sometimes they ask that question as well. But this is the answer for the number line right here. But okay with that? But all good?
Yes, sir.
All right, no answer.
Yes, sir.
Let me take that to mean yes. All right. Next question. This question now is us taking a mathematical statement and writing a mathematical expression for it. That's what this question is about. You have to be able to do that. You have to be able to do it in the real world. You have to be able to do it, and so you practice to get them to do in CSEC. All right. All right. This question says 2 adult tickets, and now don't think of it in an abstract way. Just think of it realistically. It becomes easy when you think of it realistically. So 2 adult tickets and 3 children tickets cost this amount of money, $43. Then 1 adult ticket and 1 child ticket, or 1 ticket for a child, is $18.50. Question says, let X represent the cost of an adult ticket. X is the cost of an adult ticket. I'm going to put the X right here so I remember. So what it means that if X is the cost of an adult ticket and we bought 2 of them, then it means that we spend 2 times the X, the cost of an adult ticket. And that's plus. It says Y is the cost of a child ticket, cost of 1 child ticket. We bought 3 children ticket here. So that's 3 times the cost of the children tickets. That's what we spent, 2 times the cost of an adult ticket, 2 adult tickets, and 3 times the cost of a child ticket. And that total was 43. That equals 43. $43. I'm leaving off the dollar sign. All right, we have to work with the dollar sign. We know that we're working in dollars, so we'll get the answer, put by the dollar sign, but we have to work in the dollar sign. And here now it was 1 adult ticket, just 1. Just 1 adult ticket. That is like 1x or just x. And it means plus 1 child ticket. So the amount you spend on the child ticket was 1 times x, 1 times y, because the child ticket was y dollars. So we're gonna spend 1 times y, which is y. So 1 adult ticket was for x dollars, 1 child ticket for y dollars. That total is $18.50. And we're gonna write 18.5. I do have to put the dollar sign. We know that we're working in dollars. Right? The X and the Y are in dollars. I'm just going to write 18.5. So this now is the equation for this. And this one is the equation for up here. And that's what they want us to do. They want us to write 2 equations. I'm just going to write them again. So let me just copy these down. Move them down here. So those are the 2 equations. 1850. Let's write that better. 18.5. I don't have to write the 50 and the dollar sign and all of that. This is good. They'll give it a marks for that. For X is the cost of an adult ticket, and Y is the cost of a child ticket. So when you calculate the X, you're going to put the dollar sign on it. When you calculate the Y, you're going to put the dollar sign on it. The question said no. Solve the equations to determine the cost of an adult ticket. No, an adult ticket is X. So you're really trying to find X. So look at it now. You have to do the mathematics the easy way and read that makes sense. If you want to find X, the question not asking you for Y. It's not asking you for Y. So if you want to find X, what you need to do is eliminate the Y from the 2 equations. You can use an elimination method or a substitution method. So if I want to eliminate the Y from the 2 equations, and I have a 3Y right here, then it means that I need to multiply this one by 3 so that these 2 become 3Y. So I'm going to take this one and multiply it by 3. All right. So I can actually do it right here now. That's okay. multiply this one by 3. Let me put them in this line. So I'm going to write back this first, which is the 2x plus 3y equals 43. So to find x, I need to eliminate the y. So therefore, I'm going to eliminate the y. I'm going to multiply this one by 3. All right. So I'm going to say 3 times this. So let's call this equation 1. Call this equation 2. I'm going to write 3 times equation 2. So I'm multiplying these values by 3. When I do that, this becomes 3x and this becomes 3y. 3x and 3y. And then I have to multiply this now by 3. So if I multiply that by 3, let's do it here quickly. 3 times 18.5, I'm getting 55.5. 3 times 18.5 is 55.5. So when I multiply this by 3, I'm going to get 55.5. Let me write it over here so we can see 3 times 18.5 equals 55.5. All right, so that's what we use right here. Let's leave that. All right, and then I'm solving these two equations. And so to eliminate this y, I need to subtract these two now. I need to subtract them. So this is still equation 1. Let's call this one now equation 3. This equation 3 and equation 2 is the same one. So I'm going to subtract them. But to subtract them and keep my y value positive, my x value positive, I'm going to do equation 3 minus equation 2. So I'm doing this one minus this one. All right? I'm going to subtract them. So it's easy now. 3x minus 2x is x. X equals. Then it becomes 55.5 minus 43. Because remember, I know this 3y minus this 3y. The 3y is eliminated. So I know it becomes 55.5 minus 43. When I finish, I'm going to put my dollar sign on it. So x equals, I'm going to put my dollar sign on it just to see what the cost is. I can calculate that and then put the dollar sign. So I'm doing 55.3 and I'm subtracting 55.5, sorry, subtracting 43. I'm getting 12.5. X is 12.5. So I can say, i.e., that is $12.50 is my answer for the question. $12.50 is the cost of an adult ticket. That's all I wanted. So I don't have to calculate the y. If I wanted the cost of a child ticket, then I would eliminate the y, instead, the x instead. But I go to that. But okay. This question is not asking us for the y value, so I don't need to calculate the y value. So you proceed in a way that will give you the x value. You eliminate the y. So you set it up in a way to eliminate the y because you're not asking for y. The question is not asking for y. All right, that is it. That finishes number 2. The next question we have to do is number 4, right here. All right, this is your coordinate geometry, another topic we have done already. It says the equation of a straight line is this. It's not in the standard form. The first part is asking us to write the equation of that straight line L in this form. So I want to transpose and make y on the subject of this one. All right, so let's go. Let me write it back first. 3x minus 4y equals 5. I want the y value to become positive. So I'm going to transpose the 4y over this side first. And I'm going to transpose the 5 over onto this side. So I'm going to get that the 3x minus 5 is equal to 4y. But I go to that. But okay. All right, let me assume that is a yes. And then now to leave y on the subject, I need to divide through by 4, divides by 4, divides by 4, divide all the terms by 4, or you can say multiply 2 by a quarter. Same difference. I'm going to divide 2 by 4 next. When I divide 2 by 4, this becomes 3 over 4x. This becomes negative 5 over 4. And this becomes just y. So to set it out like this, it's just a matter of turning this around, turning this equation around. So I can say that this now really then is that y is equal to 3 over 4x minus 5 over 4, which means that it is now in this form. It means that this is our gradient m, and our y-axis intercept is negative 5 over 4, the c. All right, that is it. So this is my answer right here. Simple as that. Next thing I want us to determine the gradient. The gradient is just the m. So I'm just going to write m. This is the m. The gradient is m. Is equal to 3 over 4. Let's write it down. 1 mark for it. Let's write it down. As I said, hence, this is the gradient. I'm telling him that the gradient is m. This common m right here. Next part now says, a point P with coordinates R2 is on the line L. You want to determine the value of R. Simple. If this is on the line, it means that it satisfies the equation of the line. You can substitute the values in the equation of the line. I am not going to use this one. Why I'm not going to use this one? Because there's more work. I'm going to substitute it in the original one that gave me. Do the mathematics the easy way. Because the R really is an X value. The R is really an X value that I'm trying to find right there. So I'm going to put the R value there, and I'm going to put the 2 for the Y value there. Substitute them in the equation. Let me write it back down here. So remember the equation, I'm using this one instead of this one because it's going to give me the answer quicker. This one going to give me the answer quicker. Remember this and this is the same equation, just written in a different form. All right. So I'm going to use the original one. So I'm going to write the let's put it here. Don't give a lot of space, but I'm going to write it here. The 3x minus 4y. 3x minus 4y equals, what is it again? 5, right? 5. I'm going to substitute the values inside here. So at this point, let me put it here for you now. At this point right here, the x is equal to r and the y is equal to 2. You can substitute them in the equation because the point is on the line. So this point, these coordinates satisfies the coordinates satisfy the equation of the line. So I'm going to take the x value and put it right here. So I'm going to get 3r. So I can say therefore 3r minus 4 times the y value. The y value coming right here is 2. 4 times 2 becomes equal to 5. And so now I'm solving this for r. I'm solving that for r. So I can just come and just do it right here and show what the r is quickly. If you're solving for r, what we're going to do, realize that this is actually minus 8, right? And the minus 8 is going to come over and become a positive 8. And then we're going to divide by this 3. So the r is going to become, tell me if you see it now, it's going to become 5 plus 8 over 3. 5 plus 8 over 3, which is 13 over 3. That is the value of r. But okay with that?
Yes, sir.
Yes, sir.
All right, good. All right, moving right along. It says now, find the equation of a line passing through this point. I'm going to call this point P originally. So let's call this point down here. Let's call this point Q. That's our reference. Let's call that point Q so we can reference it. All right, you can call it anything you want. I'm just calling it Q. Don't you ever call it anything, but I'm going to call it Q as a reference. And I want the line which passes through this point, which is perpendicular to L. All right, so that second line, we're going to call it line 2. Let's call that second line, the other one. Let's call it line 2. So we can reference line 2. Now, because line 2 is perpendicular to the first line, it means that it's a gradient that is a negative reciprocal of line 2. To find the equation of any line, you need to know 2 things about it. You need to know the gradient and a point. They gave us the point that it passed through. And the information for the gradient was that it is perpendicular to line 1. So we have to know about perpendicular lines. They have negative reciprocal gradient. So the gradient of this line 2 that we want, let's call it M2. is equal to -1 over the gradient of line L. Let's call that ML. We already know that the gradient of line L up here is 3/4. Let's put that ML on it from now. Put it back up here. ML is 3/4. So to calculate this negative reciprocal gradient, remember the gradient of line L is 3/4. We have that from the top. To do this calculation, the quick way to do this calculation is to flip this one and change the sign. Just flip it and change the sign. That's a quick way to do this calculation on ML. So it is going to become -4/3. You flip the 3/4, it becomes 4/3 first, and you put the negative on it. You make it negative. All right? So this now is the gradient of the line that you want. And the point they're going to use is this point. Once you have those two things, the gradient and a point, you can calculate the equation. You can determine the equation. So what is going to be the equation? Using the BFF form, what we call the BFF formula, the equation of that line, the equation of line 2, is going to be y minus yq, the point that we call q, y over that q, this point up here, equals the gradient of line 2, the line that we want, we'll call it line 2, and that's its gradient, into x minus xq. So the gradient is going to come here, and the coordinates of the point is going to go here and there. So the xq is this 6, and the yq is this 0 coming here. All right, so let's put the values in there. So the equation becomes y minus the yq is 0, the y over that q is 0, equals the gradient is this -4/3. Because it's a perpendicular line, so it has the perpendicular gradient, into x minus the x value at q is this 6. So put in 6 here. Now this y minus 0 is just y. And so I can just calculate this out now straight. I don't have to transpose anything. So it's a -4/3 times x first, giving me -4/3x. And then it's -4/3 times -6. That's going to become a positive. I know that already. It's going to become positive because minus times minus is positive. Then if you work the values now, this 6 will go 2 times into this 3. Well, 3 goes 2 times into 6. And then the 4 times the 2 is 8. So I'm going to get a positive 8. Right? If you multiply this times, this is going to get a positive 8. So it's an 8. So this right here is my answer. 4/3x plus 8. Y equals 4/3x plus 8. So are we all good? Good at that?
Yes, sir. Yes, sir.
All right, beautiful. Beautiful. Anything else to do? All right. So let's look at linear programming thing here now, linear inequalities. So the question first today, this question wants us to draw these lines on a graph. And these are easy lines. I talked here a lot about x plus y lines. So you must see that what I told in class is the truth. And these are lines that they come quite often on these questions. So you don't need to waste time calculate them. It's an x plus y line. So the x plus y line will cross the x-axis and the y-axis at this same value. So know that our x plus y line equals 10. We'll pass through 10 on the y-axis up here, and also pass through 10 on the x-axis down here. The more things you know, the better. The easier it is to do, the more things you know. So our straight line through those 2 points will be our x plus y line. It's also going to pass through 5, 5, because 5 plus 5 is 10. It's also going to pass through 5, 5. But you only really needed these 2 to get it. All right? I want to draw a straight line, but I'm going to mark this point still. Then now, this line, y equals x, is another easy line, passing through the points where the x and the y value is the same, y equals x. So it passes through 0, 0. Going to pass through the same 5, 5. It's also going to pass through 10, 10 up here, 10, 10. That's the point 10, 10. It passes through points where the x and the y value is the same, y equals x. So it passes through points where the x and the y value is the same. So the 2 lines that we're drawing is this one down here. That is the x plus y line. label it, x plus y equals 10. And I will also draw on the y equals x, which is the line right up the middle of the graph up here, like this. Use your ruler and you draw it. You can draw it right through. You can draw it right through the graph. Use your ruler and draw it, guys. I'm going to label it y equals x. All right, so we have satisfied the first part of the question to draw those lines on the graph, and I label them. All right, next part now says on the graph, on the same grid, which is graph below, I want us to shade the region which satisfies these four inequalities. All right, we want to shade the region that satisfies all those four inequalities. Now, we have to be careful. But inequality on a graph is about being above or below a line. Remember what we said in class. Greater than means above in an equation where the y on the left side is positive. So you want the value, you want the y value on the left side to be positive. All right, and then it's above the line that is associated with inequality. So for the purpose of the class, I'm going to write out each of these, what they each mean. So this one, x greater than 0. So this one really means above. The line is solid. All of them solid. Or the equal is on all of them, right? So they're all solid lines. Let me just write all solid. Let me just write all solid over here. All solid lines. So all the lines that we're working with are solid because the equal is on all of them. So we want all the lines. But this one we want above. The line we want above is x equals 0. Now, which line is x equals 0? The line associated with this inequality now is this now. X equals 0. X equals 0 is your y-axis. You have to know that x equals 0 is your y-axis. So this is above your y-axis. That's your y-axis. This is the y-axis. I'm going to put the arrow to the right. This is the line x equals 0. Let's write it x equals 0. Put the arrow to the right, meaning that the region must be to the right of this line. All right. Then this one now, the greater than over here is positive, the y over here is positive again. So this greater than means above. So this one we're going above again. It's a solid line, as we said. And the line associated with this inequality now is y equals 0. You have to know that line y equals 0 is actually your x-axis. X-axis is a line y equals 0. So this x-axis right here is a line y equals 0. I want to go above this line. So the region I want is also above this line. So the region I want is somewhere inside here. That's what we mean, right? Somewhere over here. Above to the right of the vertical line and above the line. So it's in the first quadrant. Somewhere in there. But we're narrowing it down the area. And the next line, it is this one. This inequality is the next one. The y over here is positive. So the less than means below. So for this one, now we're going below. The line is the x plus y equals 10 that we have. This line. The line associated with that inequality is this line. X plus y equals 10. So we're going below that line. So this is x plus y equals 10 that we drew. We want the region that is below that line. So let's narrow it down now. So I'm going to put the arrow below it now. Meaning that I want below this line. The region that I want is somewhere inside here now. Below this line. So we want to the right of this line, above this line, and below this line so far, which then is this triangle. So we are narrowing down the area that we want. You have to be careful. And the kicker is in the last one that they gave us right here. Let's look at it carefully, this one. So they write it, they put x greater than or equal to y. Now, plenty of people know that this now is the inequality associated with this line. And plenty of persons gonna see the greater than sign and believe they want above this line. I might end up shading here. Right? Above this line. So they would shade me here. But they would say above this one to the right of this one and below this one and shade here. But then that will be wrong. Because remember what we said is that the greater than sign means above only when the Y value is on the left side and positive. So this greater than sign don't mean above anymore. It means below, because this Y value is going contrary to that rule. The Y value must be on the left side of the inequality and positive if greater than is going to mean above. If we don't have that, then greater than means below. But we can prove it as well by recognizing that this inequality can be flipped around, because to say X is greater than or equal to Y is the same as reading it from right to left as Y less than or equal to X. These two saying the same thing. And you will see now that when the Y value is positive, we really have a less than, which means below. So it means that this inequality, whether you want to read it this way or this way, using our rule, it means below. And put it back in red. It means below. We don't want region below the line Y equals X. That's what we want. So the region for these four inequalities is actually below this one, right? Below the two lines, below this one, below both lines. The two lines that we have, these two, below both of them, right? See, below this one and also below this one. See if you try to trick you by putting a greater than here and flipping around that inequality on you. Below this one and also above this one. So the region that we want is inside here. That is it. Well, let me show you something else now. Let me show you something. Before I share, let me show you something else quick. Let me take the opportunity and show you this. Let's say you never know that definition about above or below. When the greater than sign. And you want to decide where you want that line to be. X greater than or equal to Y. It relates to this line, you know, that inequality relates to that line, right? We say that it relates to that line. So points on this line, the X value is equal to the Y value. So at this point, X and the Y value is equal on this line. You see, if you come to the right of that point, here, the Y value, the X value becomes greater than the Y value. Because, for example, look at it. At this point, let's use this point as a reference point. This point is 5, 5 on the line. 5, 5. The X and the Y value equal. If I come to the right here of the line, right, the X value here becomes 5.5 and the Y value is still 5. So you see that your X value is greater than the Y value. So the points that this inequality are referring to would be to the right of this line, which would be to the right of this one. Right? So if you're looking at it that way, you would want to the right of this line. Right? We'll talk about these. You want to the right of this line. So you'll be shading here. I still want below this one, which will be down here. And still above this one, which will be up here. So you could actually work this out and get the inequality. But to just keep it simple, just use the same definition that I gave you in class, which is that greater than means above only when the Y value in the equation of the line is on the left side and positive of the inequality. You have to remember that when the Y value is on the left side of the inequality and it is positive, the greater than means above the line and the less than means below the line. If you can remember that, then we're good. All right, we won't have a problem. So let me go back to the region that we wanted. So the region that we want is this one. Since I'm trying to spend some time to first so understand this clearly. That is the region for this one, guys. Are you good at that? But okay?
Yes, sir.
Yes, sir.
All right. So I wanted to work these questions over again now.
Remind me.
Watch over the video.
Yeah.
Watch over the video. Mute your mic, please. Mute With the mic. All right. And you need to go somewhere where there's nobody talking in the background to distract the students. When you have class, you need to go somewhere where there's nobody in the background talking and distracting you. You need to focus on what we're doing here. All right, as much as possible, try to go somewhere quiet where there's nobody around you talking and distracting you. You're not gonna get the full benefit of the class. Now, that's why I don't like the online classes so much, you know. I like prefer the face-to-face. Because we're just in a space we can have one singular focus. That's why we need to get back to the face-to-face class, all right? Because I know that the environment sometimes is not the best for the class, for you to learn and understand. And when you have classes, you can just ask the person around it to try and just, you know, try and just give you a chance, just be quiet a little bit and give you a chance to focus. All right? That's what it is sometimes. Let's go. All right, so this question says, show by calculation that the exact root of this equation are these. Now, this comes from a quadratic formula, guys. So the square root there, you must know. Right? So what it is that you really want to solve this equation using the quadratic formula. You can also use complete and the square, but the straightforward way really is with the quadratic formula. So in this equation here now, the a is equal to 1. It is already in the standard form. You can drop the values in the quadratic formula. A is equal to 1 because the coefficient of x squared right there is 1. The b is equal to 2 because the coefficient of the x right here is 2. And the c is equal to -3. This c is equal to -3. You have the 0, so you can use the quadratic formula. So we're going to drop these values in the quadratic formula. Let's remind ourselves that the quadratic formula, it is that x is equal to minus b plus or minus the square root of b squared minus, let's write that properly, b squared minus 4ac. This is on the formula sheet, guys. This formula, everything over 2a. And let me repeat it again. A common mistake is for persons to put this part alone over the 2a, which is wrong. It is everything over the 2a, all over 2a. I think the formula is on the sheet here. Let me bring it up and show you. Quadratic formula. It's on the formula sheet that comes with the exam paper, but don't want to depend on that. We don't have time for looking for it. 0 must be when it is equal to 0. This becomes, these are the root. See? It is everything over the 2. That is it. Remember, you can come to the, we don't want to depend on that. But that takes time. Get it in your head. Learn it in your head. Your head can take it. It can take everything you need to learn in school, you know. Your brain has the capacity, everything that you need and know in school. I'm careful with the negative signs now. Eh? That's minus b. The b is just 2, so it becomes a minus 2. Plus or minus the square root. And the b again is 2, so it's 2 squared minus 4 times the a. The a is 1 times the c. The c is a -3. I have to care for this negative now. Minus 3. I remember now it's everything over the 2a. 2 times 1. When I write this down, if you put this in the calculator now, guys, some calculator, if you put it in there, it's going to give you that. All right? It's going to give you that if you put it in the calculator. And some calculators actually can solve the quadratic equations. You have calculators that can do that, but see if you want to see it work, right? So you can just drop it in there and depend on that. So this becomes x equals minus 2 plus or minus. Then this is a 4. And this becomes really a positive 12. This is a positive 12 because the minus 4 times 1 is -4 times a -3. So -4 times -3 is a positive 12. I can put a little 12 above this, like a plus 12. Remind me. So it's really 4 plus 12 is 16. So I'm having 16 under here. 16 that can be 16. This is 4. That's right. So then we get the 6. I'm getting the square root of thing. That can't write something on 4ac. Let's make sure. Oh, so the mistake here. I have -5. There's a -5 that I have. I put 3. It's 5.5. See, that's another thing. You have to be able to see your mistakes, guys. So this is actually a 3, a 5, I mean, -5. As I was getting 16, which will give me a perfect number, right? So it's 4 times A, which is 1, times -5. All right, better. All right, so this then is a positive 20. So write a positive 20 right here to remind me that this is a positive 20. All of this is a positive 20. And then this is 4. So 4 and 20 is 24. So I'm going to put the 24 under the square root sign here. And you're dividing that by this 2. So I might say to yourself, how would they go from this to this? Where that root 6 comes from? Now, as I said, if you put this in the calculator, it might just give you that. But let me show you what happened, right? To get to that 6. Show you down here. Now, this 24, what they did, they tried to write it as a product of a perfect square. Factorize it. And I want a perfect square as one of the factors, which is 4. So you write it as x equals -2 plus or minus the square root of 4 times 6. 4 times 6 is 24. That's what the 6 came about. And still dividing this by 2. But the square root of 4 times 6, let me write over here in red. Square root of 4 times 6 can be written as the square root of 4 times the square root of 6. You know? Can break it like that. You know? Right? If you're able to do that, as you go, you learn. All right? This is square root of 4 times the square root of 6. Maybe another time I explain to you more why. But the square root of the 4 part is 2. Square root of 4 is 2. So it really becomes 2 times the square root of 6. So this expression right here is 2 times the square root of 6. And some character will show you that this square root of 24 reduces to 2 times the square root of 6. Where this is called a surd. So some character will work the surd for you. All right? So we can replace this with 2 root 6. 2 times the square root of 6 says x equals -2 plus or minus 2 times the square root of 6 all over 2. And then now it is like you're dividing this by the 2 and you're also dividing this by the 2. So you divide each part by 2, you're going to get x equal this part divided by the 2. You have to be able to divide everything on the numerator to proceed. This can be divided by the 2 and give me -1 plus or minus. This divided by the 2 will 2 will cancel and give me back the root 6. I'm left with root 6. And that's what they told us to show. So I can say show. So a question like this now, guys, again, you're going to work it over again because they don't set it like this very often. It's like a special question, not difficult, but you know, you want to be mindful of questions like this. Where you have to do this like a breakdown in particular. All right? You have to do that like a breakdown. But the calculator, some calculators will work it out for you, but I don't know if you get the full marks if you just drop this in the calculator and get that. I don't know if you're going to get the full marks if you just drop this in the calculator and get this one. I don't know if they're going to give the full marks if you don't show this step. So you practice it and show it an exam because you want to make sure you get the marks. What good at that?
Yes,
okay? All right, good. What else are we to do? Oh, we have to solve this pair of simultaneous equations, right? And but we have simultaneous equations of a line and a curve. I will normally substitute the line equation into the curve equation. Let me write them out back for you so I can show the substitution for you. So it's 2 plus x equals y, and it is xy equals 5. Those are the two equations. And I'm saying at the points of intersection, because remember now, we're solving equations simultaneously. You're finding the point where they meet on a graph, where the x and the y values are the same on the line and on the curve. So we're trying to find where the point where the y value on the line, which is this, and the y value on the curve are the same. Also, the x value on the line and the x value on the curve are the same. That's what you're trying to find. So because they are the same, you can substitute these two for each other. But the line is saying that the y is equal to this. The line equation is saying that the y is equal to this. So I can use that the line is saying y is equal to and substitute it for what the y is in the curve. And that's how we can make that substitution, but the y values are the same. So I'm going to substitute the line equation into the curve equation. This one is a line equation. This one is a curve equation. I might ask how I know that this one is a curve. Because curves usually have products and quotients of x and y in them. So when I say x squared in our equation, I know it's a curve. Y squared, I know it's a curve. XY, I know it's a curve. X over y, I know it's a curve. Curves usually have these expressions in them. If it's like square root of x and all those things, those are curves. The lines are the ones that you can rewrite in the form y equals mx plus c. They usually have the x and the y values as separate terms. Those are the lines, all right? So that's a line and that's a curve. And the method we mostly use when we're solving these equations is to substitute the line equation into the curve equation for one of the variables. That's what we normally do. Substitute the line into the curve as we are doing here now. So I'm going to say substitute the line into the curve. Let's write it down. I'm going to sub the line into the curve for the y. We're substituting for the y as I've indicated here. So we make that substitution. This is going to become x times the 2 plus x equals 5. That's what this becomes when you put the line into it. That's what it becomes. And so you're now solving an equation with x alone in it. It's actually a quadratic equation. I'm going to just set it out like a quadratic right away. So it becomes x times x is x squared. Let's do that part first. Then x times 2 is 2x plus 2x. And then this 5 comes over and it becomes a negative 5 equals 0. Now the question did say hence, right? So it means that it has something to do with the first question. If you look carefully, it's actually the same equation that we solved. Right? It's the same equation that we're solving now. X squared plus 2x minus 5 equals 0. So it means that we already know the x values. There are negative 1 plus root 6 there, and negative 1 minus root 6. So the x values down here, if you look at it, so this equation, we already know the values. So we can write them here. This equation is giving us the same values from before, which is x equals minus 1 plus the square root of 6 is 1, and the other one is minus 1 minus the square root of 6. That's what the plus or minus here meant, right? Here. Means that there's one value with the plus and another value with the minus. And we wrote them down now, separately down here. So we need to find the y values now. We need to find the y values to go with these two x values. So to find them, we want to substitute them in the line equation for the x each time. All right, so let's do it here now. So with a lot of space, let me make this a little bit smaller. Make this a little bit smaller. So have some more space to write. All right, and zoom it up. All right, so now I'm going to substitute for the x first. So let me write, I'm going to substitute into the line equation, which is now y equals 2 plus x. I just conveniently split this around and put y on the left side. It is equal to 2 plus x. I'm going to substitute first this x value here to work out what the y value is. All right, so I'm going to get when the x equals minus 1 plus root 6, the y value becomes 2 plus this, which is minus 1 plus root 6. So it really becomes 1 plus root 6. So one point of intersection has this x value and this y value. I'm going to write it. So it's minus 1 plus root 6 is my x value, and 1 plus root 6 is my y value. That is one point. This is one point of intersection. The other point is where the x equals this. So I'm going to say now, when x equals minus 1 minus root 6, the y value becomes 2, and I'm adding this value now, plus x. So I'm going to put this value over here now. Right? just adding it. So I'm going to get -1 minus root 6. And that becomes 2 minus 1 again is 1 minus root 6 minus root 6. So it means that when the x value is this is the y value. And so that gives me a second point, which I'm going to just write it right here. It becomes -1 minus 1 minus root 6. And then it is this y value, which is 1 minus root 6. And so these are my two answers. That's one answer. And that's my second answer, my 2 points. Oh, Steve, are you good with that? But okay?
Yes, sir.
All right. So remember, guys, I'd appreciate if you go and do these questions over again by yourself because they are different. They are a little bit different, right? Questions that are different, you need to work them over again. Right, this root 6 better. Okay, those are my 2 points. All right, so this question now, down here, it's a curve. I mean, yeah, we never really do this, but we can do this question. We can do this question. All right, even though we don't do it at that topic, it's just basically drawing a graph, right? So they give us the incomplete table for the function y equals 2 to the x. All right, y equals 2 to the x. So what is it that we calculate these values on 2 to the x on these x values? So we have to complete the table. So for when x equals -1, like I put the -1 up there for the x. And so the y becomes 2 to the -1, which is going to be 0.5. Zoom it up. All right, make the pen smaller. All right, so it's going to become 2 to the -1, because the x is -1. You're going to get 2 to the -1. And 2 to the -1 is a half, or 0.5, if you can calculate it. Then this one is 2 to the 0. That's why I get the 1. Then this one will become 2 to the 1. X is 1, so it's going to become 2 to the 1, which is equal to 2. Then this one is going to become 2 squared. 2 to the power 2. 2 squared, which is 4. This one is 2 cubed, which is 8. This is good. And this one now is 2 to the power 4, which now is 16. So those are my values. Half, 2, 4, 16. I'm going to show the calculation on them in them as well. And you can do that. You can do that. So see how you get your values. Those are my values. Then it wants us, first it wants us to complete the table, which is what I've done. Then it wants us to draw the graph, right? Using a scale of 2 centimeters represent 1 unit on the x-axis and 1 centimeter represent 1 unit on the y-axis. So on the x-axis is 2 centimeters to 1 unit, but on the y-axis is 1 centimeter to 1 unit. That's what they want, all right? So let's go and see this graph that I want us to use. So on the x-axis is 2 to 1. So this is like 1 right here. If we're to scale it 2 to 1, this is 2. Right? Right here will be 3. Right here will be 4. How far did they go? They went from -1 to 4. So let's go back to -1. Right here with -1. That's your 2 centimeters to 1 unit on the x-axis, right? So those are your values. And the y-axis is 1 centimeter to 1. So this should be 1 and this should be 2. And then this will be 3 and this will be 4. And this will be 5 and this will be 6. Because 1 centimeter to 1. This will be 7 and this will be 8. I think our values went up to 8. No, it went up to 16. This will be 9 and this will be 10. This will be 11 and this will be 12. 13 and 14. 15 and 16. So we went all the way up there. 16. All right. So that is the graph. That's a scale. All right. There is 0. All right. Put in the values now. All right. So what I'm going to do, I'm going to write down the values and then copy them down. So the points were -1, 0.5, then 0, 1, then 1, 2, then 2, 4, then 3, 8, then 4, 16. Right? These are the points from these values, right? I'm going to copy this down. So I have it in front of us working with on the next page. All right, let's go down here. I'm going to put them down here. All right, put them here, so. So the first one is negative. Let me use a red ink. Put on the points, right? -1, 0.5. -1, 0.5. All right, so this is -1. This is 1. This is 1, you know. So 0.5 is here. We're talking about this point. That's the first point. The next point is 0, 1. 0, 1. 0, 1 is right here. Right here. 0, 1. The next point is 1, 2. 1, 2. 1, 2 is this point. Right there. The next point is 2, 4. 2, 4. 2, 4 is right here. The next point is 3, 8. 3, 8. And then 4, 16, right? 3, 8 and then 4, 16. So 3, 8. 3, 8 is right here. And then 4, 16 is all the way up here. So the 4 here coming all the way up to 16, right? Which is right here. So basically drawing a smooth curve through those points. It's a curve you're gonna get. You have to draw a smooth curve through those points. So I'm just gonna draw it like this. Done. I'm just gonna do that. I'm doing this with my free hand. You're gonna have to do it with the free hand as well. Don't put any ruler on it. It's not a straight line graph. Not a line segment graph. It's a curve. So just draw the best curve that you can have. If you can have one of those flexi rulers, right, or one of those curve rulers, then you can use it on it and draw it. All right, that is your graph right there. But I good at that?
Yes, sir.
All right. So we have done the graph bit. So we did it and we did that. The next part now says we are to draw an appropriate straight line. By drawing an appropriate straight line, determine the value of x for which 2 to the x is equal to 11. Now, what does this mean? It really means that you want where the y value is equal to 11 on the curve. Because remember, the curve is y equals 2x now. You want where y is equal to 11. So the line to draw is this line. Y equals 11. You need to draw y equals 11 and see where it intersects the curve y equals 2 to the x. Okay, this equation comes about from y being equal to 2 to the x and y equals 11. So because you already have the curve, y equals 2 to the x, the line that they're talking about to draw is line y equals 11. All right? And line y equals 11 is an horizontal line passing through 11. So this solution is obtained by getting the point of intersection of this line with the curve. All right? So that's what we have to do. Y equals 11. So come on the curve. Let's use a green ink for that. Or purple. See 11 right here, so this is 11. The line y equals 11 is this one. The line to draw is this line. Y equals 11. Y equals 11 is the line that we are drawing. And the curve is y equals 2 to the x. That's right. The curve is y equals 2 to the x. So the point where 2 to the x is equal to 11 is a point of intersection right here. Let's go back for the purple or the black or the green. Question is talking about this point where they intersect right here. And we have to read that down on the x-axis. We're talking about this point. So we can write it at this point where they intersect. 2 to the x becomes equal to 11. And it's a matter of finding what is that x value. You read it on the graph down here. So when I come down and read it down here on the graph, and then we can use the calculator and check it, see if it makes sense, if the answer is correct. All right, when I put the calculator and see if the answer that we get, give us anything close to it. Based on this sketch, remember now, there are 10 lines between 0 and 1 over here. 10 lines. So each of those little lines is 0.1 because it's 10 spaces, is 1 unit, sorry, 1 unit divided by 10 spaces. So each of these little lines is 0.1. All right, 0.1. So right here then will correspond to 3.4. This is 3.4. 3.4. X equals 3.4 right there. So we are saying the answer is 3.4. So based on that sketch, the answer for this, let's put it, is x equals 3.4. Let me take these off. We didn't need these now. Let me take them off. We'll just put them there for the graph. Right? So I'm saying that this is the answer. This is the answer, 3.4. And I'm going to test it with the calculator, see if we get anything near to 11. I'm going to plug the 3.4 in the formula 2 to the x and see if we get 11. If it is true, then 2 to the 3.4 is supposed to be a value close to 11. Let's see. So 2 to the 11 power, 2 to the power 3.4. So 2 to the 3.4. See, we get 10.5. Close enough. We get 10.5. If we correct it to the nearest whole number, you're going to get 11. So 3.4 can work. 3.4. All right. So it all depends really on how you draw the sketch or you sketch the graph, because some person might get 2.3, might draw the graph and it pass through here. So instead, or I might draw, you understand me? So, but 3.4 is a good answer. 3.4 is a good answer. I can work out and tell you what the precise value should be using logs. 2 to the x equal 11. You're not going to do this, Then x log of 2 is going to be equal to the log of 11. So the x is going to be the log of 2, log of 11 over the log of 2, or the log of 11 to base 2. So we can work it out and say log of 11 over the log of 2. You're not going to do this, guys. 3.45 is the precise answer. 3.46. 3.46 is the precise answer. But I don't think you'll be able to get that on the graph. So 3.4, maybe they wanted 3.5. Let's see which of the answer is better. So 3.4, I'm getting 3.4. Maybe somebody else would draw the graph and actually get the 3.5. Because they might have drawn it. Use the black ink and show you, or somebody might have drawn it. Somebody might have drawn it this way. And it passed to the 3.5 for them right there. But you have to just present the answer that you got. So maybe another day when I draw it again, I might actually draw it in black as I'm showing here. And then I would get 3.5. But if your graph give you the 3.4, believe me, CXC is going to give you the marks. The precise answer is 3.46. The most accurate answer to 2 decimal places is 3.46. Right? And if you correct it to 1 decimal place, 3.5. So maybe the answer they're looking for is 3.5. But questions like they usually give a range of values. So let's say the answer that they're really looking for is 3.5. CXC will say, okay, anything up to 3.6 and down to 3.4, and maybe 3.3 and up to 3.7. Anything within this range, they will give it the marks. That's how CXC mark the paper, because not everybody is going to draw this curve the exact same way, because you're drawing it with your hand. You're not a computer to draw the precise thing. All right. So the 3.4 that I wrote here is a good answer, but I think a better answer would be 3.5. So if you draw it and get 3.5, no problem. But 3.4, you will still get your marks. I better go to that. I think that finishes this paper for us. Yes. Finishes this paper. I better go. About okay with this? So we
Yes, sir.
All right, what time is it now? How long we been going now? We don't reach 2 hours yet.
Sir, almost 2 hours, sir.
Almost, all right. More maths equal better maths. Because we use up the time. More maths equal better maths. I want to show you something, right? I was researching for a particular question and I found one. And let me show you, all right? Or sometimes they change the wording of those linear programming questions. Let me show you what I'm talking about. So this was 2007. All right, I'm going to show you something quick. All right, this linear programming question. I'm going to bring up our screen over here for you. Right on. Let's do this. 2007. All right, so look at this question now, guys. Because sometimes they will do this thing, and I just want to expose you to it from now, such that if you get a question set out this way, then you can still work. Let's look at this question. We're not going to draw the graph and all of that. I just want to point out something to you, right? So this question says, Pam visits a stationery. It's a linear programming question, this. So Pam visits a stationery store where she buys X pens and Y pencils. So she buys X pens and Y pencils. Hold on a second. X is the number of pens. Y is the number of pencils. Remember, you don't know X and you don't know Y. You don't know how many she's going to buy. So X is the number of pens, Y is the number of pencils. I'm going to give you some conditions on which you buy the pens. She buys the pens and the pencils. The first condition is that she must buy at least 3 pens. And buys X pens, Y pencils. No, at least 3 means that she must buy 3 or more pens. So I don't want us to write an inequality for that. It has to be that X is greater than or equal to 3. X pens, the number of pens X must be greater than or equal to 3. So that's first inequality, X greater than or equal to 3 that I have there. Next part now said the total number of pens and pencils must not be more than 10. Can't pass 10. The total must be 10. So the total is X plus Y, guys. X plus Y. So it's X plus Y cannot be more than 10. It can be equal to 10, just can't more. So that inequality is that the total pencils and pens that you buy must be less than or equal to 10. That's the second inequality. So I think those two are pretty normal. So the one that I want to point out to you, this is the one that I want to point out to you. So don't set it like this pretty often, where you have to interpret the information that they give you. So let's look at it now. It says, each pen costs $5. Each pencil costs $2. It says more information about the pens and the pencils are represented with this. So sometimes what they do, they give you the inequality. And you have to interpret the information from the inequality. Right? Remember what they say now. Each pen is $5. So you're spending $5 on the pen by buying X pens. Plus, each pencil is $2. And you're buying Y pencils. So you're spending $2Y on the pencil. So this is the amount of money that you're spending. 5X plus 2Y. Then it says more information about the pen and the pencil is presented with this. And their question is, write the information represented by this inequality as a sentence in your own words. So oftentimes they ask you to do that. What does this inequality mean in your own words? And the question is referring to the cost, how much money she spends to buy the pens and the pens. Anybody can tell me what you think this means in your own words? Just tell me what you think it means. 5X plus 2Y is less than or equal to 35. What does it mean?
Sir, you can only have the two of them combined being less than 35.
Two of them, what you mean? Remember now, this is about the money that she spends. She spends $5 on each pen, $2 on each pencil. So this is the amount that she spends on the pen. 5 times X, $5 times X. If I want to put a dollar sign in front of it, no problem. This is the money that she spends on the pencils, $2 times y. And they give us this inequality, that 5x plus 2y is less than or equal to 35. So come again. Think and come again. Think and come again. Try again.
So the total amount spent has to be either less than or equal to a 35.
$35. Beautiful. That's it. This represents the amount that she spends. It's just that they have not put the dollar sign on it. Because they could have put 5x dollars plus 2y dollars less than or equal to $35. But as I tell you, they don't normally put the dollar sign in the equation. They leave it off. But it's not relevant to the equation. And that's what they have presented. So you have said it correctly. The total that she spends, she's spending no more than $35. That's how we can say it. She spends no more than $35. I can say she only has $35 to spend to buy the pens and the pencil, anything like that. The total amount that she spends to buy the pens and the pencil cannot be more than $35. She spends no more than $35 to spend on the pencils. She spends a maximum. The maximum she's prepared to spend on the purchase of the pens and the pencils is $35. Any statement like that will be good. So what you said is good. Everybody understand that? Other persons understand that? You have to remember stuff like this, guys. Questions like these. You don't know what's coming on your exam. It's special. It is special. You must remember these special things. Why is it special? Because it's not the regular thing that they ask. All the linear programming questions we have asked that we have done so far, they have not said anything. We don't say anything like this. So far, I forgot to dig it up 2007. Because I have these things in my head. So I go searching for it to present it to you. It can pop up on your exam paper as well. So a statement here would maybe be that she spends no more than $35 to buy the pens and the pencils. Anything like that. She spends no more than, I put the dollar sign, $35 to buy the pens and pencils. That's a neat way to put it. But if you want to read out the equation, the inequality, and say the total that she spends must be less than or equal to $35. They will give the mark still. But I think sometimes the answer that you give them is how they would present it to you in a question normally. You get me? So this is how they would present it to you normally in a question, and then you would write this inequality from that information. But this time now, they are giving you this. So what you do, you give them back the statement that they would normally write in the question. Give it back to them the way that they would normally write the question. And that's why it is so important that we practice a lot of questions. So these things come like second nature to us. We have to practice. So far back ago, 2007. I know none of you are on the call and born yet in 2007. Well, maybe some of you were born already, but you were like babies if you were born. If you're born 2007. My boy, so far back, I have to go to find a question. And I have another one. And then you'll proceed in a normal way. You draw the graph for this, draw the graph for that, draw the graph for that in the normal way that we have been doing, right? I see they're saying on the answer sheet, draw the graph, and then say write the vertices, we to get the vertices as normal. And then they tell us about the profit now, right? Depends also expense and why pencils to make a profit. Wants to make a profit of $1.50 on each pen. So the profit on the pen is 1.5x. That's a profit now. And $1 on the pencils. So that is plus 1y. I don't have to put the 1, so just put y. So this is a formula that for the profit that she's making. I'm saying this is the expression. See, they write the expression. So you see, the rest of it is normal. These are the normal things that they're asking the question that we've been practicing. And then they wanted to calculate the maximum profit. Remember, you go to the vertices of the shaded region. of the common region to find out, and you normally have to test at least 2 of them. And then this one says, no, if Pam buys 4 pens, show on your graph the maximum number of pens that she must buy. So in that case, that's another good question. You know? You should buy 4 pens, right? So it's like, let me show. It's like, so how you would answer this question. Let me give you like an indication of how you would answer this question. Let's do like a quick sketch and show you how you'd answer that part. So I would draw for x greater than 3, this one. So I'll get a line up here. Let me draw it in black for you. I'll get a line up here for x equals 3. Then I'll have to draw a line x plus y equals 10. So I'll get the line coming down here, x equals 3. Then x plus y equals 10 will go like so. X plus y equals 10. I want below that line. And then we'll have to draw this one. This one would be the line related to 5x plus 2y equals 35. And that will be another negative gradient line. If we put in 2 points on it quickly, we would have x equals 0, y equals 0. So you put in x equals 0, you get 2y equals 35. 35 divided by 2 is 17.5. It's about 17.5. And then where y equals 0, you're going to get 5x equals 35, means that you're getting 7. So you're getting 7. So up here says 10. Let's just put like a quick thing. Up here says 10, down here says 10. The other line passed through 0, 17.5, which is way up at the top, and 7, 0. Oh, hold on. I'm putting the wrong thing. This is 10. Right, so this one is 7, 0, which will be here, somewhere around here. So the other line would basically go maybe like so. Somewhere up there, so. Right, the other line will go somewhere up there, so, right? Somewhere up here. I remember I say going up to 17.5. Up here, so at 17.5, right? This other line, this one, right? So, and then no, so your region now, anything else? So it's 4 lines, right? 4 lines. So your region will basically be inside here. That to be a region, you know. That to be a common region. So the question is, what would this point be? I don't know. I'd have to work it out, right? It is the intersection of x plus y equals 10 and this other line. This other line is 5x plus 2y equals 35. I'm not going to waste time and work out what this point is, all right? But that might be the vertex that gives the maximum price. You'd have to test these two to see which one it is. You have to find out this point on the graph, this point on the graph, and test them. This point will clearly be 3, 7. 3, 7. That one easy because you know that the x plus y must equal 10 on that line. So that point is 3, 7. And then you might have to work out this point, where that point is as well. It's also on the line where x plus y equals 10, you know. So maybe it's 4 something, like 4, 6. Would 4, 6 work? We can test them, you know, quickly on this equation. 4, 6. So it's 5 times 4 plus 2 times 6. That will be 20. No, so it's not 4, 6. Let's try 5, 5. Let's see if it is 5, 5. Let's see if it is 5, 5. If it is 5, 5, to be 5 times 5 plus 2 times 5. This will be yes. So this point is 5, 5 actually. Wow, quick and fast. This point is 5, 5. All right. So that point will be 5, 5 if you do it. And then now your maximum profit. And you might have a test this point as well. Where that point is what? That point we said was 7, 0, right? 7, 0. All right. So to work out the maximum profit, which was P equals, it's almost like I do in the question. P equals 1.5x plus y. You have to plug in these values in this equation to see which one comes out the maximum, and maybe this one as well. Okay, you can't know which of those 3 points it would be, but that would be a region, right? So you plug in the 3 of them in this equation and see which one comes out to be a maximum. Might actually be this one down here. I don't know, right? So you can work them out. But I'm answering this question for you now. This question down here, which says if she buys 4 pens, you know what that means? It means that x equals 4, you know. This means that x is equal to 4. What is the maximum number of pencils she can buy? So how you wrote that out? Let me zoom this out. How you wrote that out? Do it in purple. Is that you'd have to come on the graph, like right here. Like maybe right here. If x equals 4, well, it's right here, so it's 3. I must say right here, so it's 3. You know? Right here, so it's 3. So the point you're talking about would maybe be somewhere around here. X equals 4. You have to come up on the graph up here, so now. It's almost like you're trying to reach this point. So if x is 4, then the maximum she can buy of pens she can buy is right up on this line, which will be 6, because this point will be 4, 6. That's the maximum she can buy to satisfy the region. So the maximum she would have to buy is 6. She can buy 6. Y has to be 6. That's the maximum. She can buy any number of pens, any number of pens, any number of pencils. For 4 pens, she can buy any number of pencils inside here. All the way up to this point. She can't go past this point. And because it's on this line, that's why I know it is 6, 4, 6. If it was a value down here that is corresponding to the intersection of this point, or on this line, I mean, then you again have to go up to this maximum and see where that maximum is. And if the point up here can't work, because you get something like maybe, so we're getting something like 3.5. They can't use 3.5. You have to come back in the region, right? For here and come to a point there if you cannot go on the line. Okay, you can't have 3.5 pence. Think you understand that, guys? I'm trying to explain this question. Think you understand that?
Yes, sir, I understand.
Yes, sir.
Good. I kind of bomb your shit, but I just want you to understand. Let me show you another question now. Let's set a different way again. And I think it was in the same, I think it was 2006 May. But I have it in my system as 2007. Another 2007. So, you know, that was the nature of the questions back in the day, and you can get questions like that again. Right? So this says June 2007, but it was actually 2006. Let's look at it. See here? It's 2007. Okay, 2007. Let's see if it's this one I want to show you. Let's see if it is actually this one I want to show you. Let's see. Just want to show you different ways that they set the questions sometimes. All right. There's actually 2007 right here. All right, no problem. Maybe one that we looked at a while was really 2006. Let me see. This is actually 2006. Let's see. Yeah, see, this is actually 2006. See? I have it in my system as 2007, but it's actually 2006, right? But, and then now, 2007 now is this one. No, not that one. Just the wrong thing. 2007. This one. I'm going to show you another way how to present the question sometimes, right? Get comfortable with these things. So look at this one. Another way to present it, another way to us. Just to show you the different ways. Remember, this is our last topic in the linear programming. It says, a company manufactures gold and silver stars to be used as party decorations. Right? It says the stars are placed in pockets so that each pocket contains X gold stars and Y silver stars. So again, it's X and Y. So X is the number of gold stars, Y is the number of silver stars. You don't know X and you don't know Y. It says the conditions for packaging are given in the table below. So they give you the conditions and the inequalities here. Similar to how I did with the class thing when we introduced this topic with the boys and girls. Similar. When they give you the condition, you have to write the inequality here. And they do the first one for you. First condition is that each pocket must have at least 20 gold stars. At least 20 gold stars. Remember, the number of gold stars is X, you know, so it's X gold and Y silver. They don't know X and I don't know Y, but the number of gold stars is X. And if it must have at least 20 gold stars, It means that the number of gold star, which is the X, has to be 20 or more, which is greater than or equal to 20. That's the first inequality for that. So that would be correct. The next condition is this one, but no, you have to write the condition for it. And that's how they present it. What is it? It says each packet must have at least 15 silver stars. So it means that the number of silver stars must be at least 15, means 15 or more. So the inequality for that one that we have to put here would be that the y is greater than or equal to 15. That would be the condition there. And this one now says that the total number of stars, the total number of stars in each pocket must not be more than 60. Not more than 60 means less than or equal to 60. And the total is really the X plus Y. The number of gold plus the number of silver star must not exceed 60. So it means that X plus Y has to be less than or equal to 60. That will be the condition for that one. And then now they give you this one, and you have to write the meaning for it over here. Remember, you know, guys, has to be in terms of the number of gold stars and the number of silver stars. That's what it is, because this is the number of gold stars, that's the number of silver stars. So tell me now, what would you have to write for this one? Or what could you write for this one?
Which so for
Come again, you're gone.
that's just saying for every gold one you have 2 silver ones, right?
Nope.
Oh.
Read it as it is. Just remember, X is the number of gold stars, Y is the number of silver stars. So come again. X is the number of gold. That's what you have to understand, you know, guys. You have to understand that, you know, X is a number of something, Y is a number of something. So just say that. X is the number of something. What we're doing is linear programming questions. X is always a number of something, and Y is always a number of the other thing. That's what you have to see X as and Y as. Number of this, number of that. So tell me now again. Read it for me again. Come on. Simple. Don't complicate it. Don't try to style it up. Just read it as it is. X is a number of gold stars. Y is a number of silver stars. So say this for me now with those terminologies. Number of gold stars, number of silver stars. Come again. Try again. Or somebody else want to try. Come on.
The number of gold stars is less than 2 times the number of silver stars then.
Good. But what you want to do sometimes is think of how CXC would have said it. That is okay now, that is fine, you know. But instead of saying 2 times, CXC would have said the word twice. So he said twice. The number of gold stars must be less than twice the number of silver stars. That's what they would have said. When you are writing the statement, when you are writing the inequality in your own words, try to mirror the way CXC would have written it in a question. Because that's what they are doing, you know. They're just flipping it around. Normally, they give you the statement and you write the inequality. What they are doing is flipping it now, and they are giving you inequality, and you have to put it in your own words. When you are putting it in your own words, all I'm saying to you, try to mirror or say it the way they would have said it. And you're able to do that when you practice and you do a lot of past papers, and you get to know the language. When you're doing biology, you have to use the language of biology. You have to use the terminologies in biology. Even if there are other ways to say something, you have to use the terminologies for biology. When you're doing chemistry, even if there are other ways to say certain things in chemistry, you're using the language of chemistry. When you're doing physics, it's the same thing. You use the language of the physics, even if there are other ways to say things. If you notice how doctors talk, when doctors are communicating with each other, they use certain terminologies that are medical. When lawyers are talking in court, they don't talk simple straight. They use the language of the profession of law. Right? Sometimes we don't even understand it, and they can say the same things in simpler ways for us to understand, but no, they use the language of law when government and and ministers are in parliament talking. They use the language of parliament and the language of government and the language of politics. So therefore, when you're doing mathematics, you use the language of mathematics. Instead of saying 2 times, for example, you say it twice. 6 is still going to give you the marks if you say 2 times, you know. I'm not saying no. But we need to practice to use the language of the subject that we're doing. But that's what I'm trying to say. Understand?
Yes, sir.
Good.
Yes, sir.
Good. So for this one, what you said is correct, and you get the marks. But X is the number of gold stars. I'm going to say that. Because I don't have enough space, I'm going to write NO for number, right? The number of gold stars must be less than that's what this means, less than. And this is twice the number of silver star. Less than twice. That's what 60 would have said. Twice the number of silver stars. If you write that, to get the full marks. All right? And then now, watch this now. They want to write down inequalities for part 2 and 3, for 2 and 3, which is what we just did. And then you have to describe in words the condition for this one, which is what this is, right? So you done those 2 parts. Bam, bam. Then here now, they want to use a scale of 2 centimeters to 10 units on the x-axis and both axes to draw the graph for all 4 inequalities. So drawing those again now. Same kind of thing. And then now, they wanted to share the region. So it's because this now has y on the left side. Look at it good. See? Instead of reading it like this, I prefer to recognize it as 2y greater than x. Because if I go focusing on the left-hand side, I might shade below the line. You're going to draw this line, you know, which is 2y equals x. You know, the line related to this inequality is 2y equals x, which is same as y equals half x. You know. I'm going to draw that line. It's going to shape like this. You know. But if you focus on this inequality, you might end up shading below the line, which will be wrong. Because this inequality is the same as this one. We just turn it around. And now because the y is on the left side and it is positive, the greater than means above. So you really want above that line, not below. But because they've put the equal on it, the less than on it, you might go and think it's below the line you want after you draw the line, which will be wrong. And that's why we have to cement the definition of what the greater than is and what the less than is under the caveat that I gave you, which is that the greater than means above when the y on the left side of the inequality is positive. Otherwise, it means below. So in this case, less than does not mean below because the y is on the right side and positive. Right? So the safe way to know what it is to write it the way that we want it. So flip it around. And we see that it's a greater than sign we have, so it's really above it means. All right? So the rest of it is the normal thing. Just for this, just to recognize that when you draw the line for this inequality, which is a 2y equals x, which is going to slope up like that with a positive gradient, which is the same as y equals half x. It's the same as y equals half x is the line that you want. And pass through the origin as well. You have to go above this line. The region that you want is above this line. And you're combining, right? We know that this one will be below the line x plus y equals 60. This one be above the line y equals 15. This one be above the line x equals 20. All right, so a question like this, I'm gonna just sketch it through. I'm gonna sketch it through. Let's just do it. I'm gonna sketch it through quickly. Because I also want us to do this part down here. All right, so let me just sketch it through for you. Let me put on a y-axis and an x-axis, quick and fast. All right, and let's sketch it through. Let's do it. All right. So we're going up by 10. So like 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. That's the x-axis. 10, 20, 30, 40, 50, 60. That's the y-axis. I'm going up to 60 because of this line. All right? All right. Let me come over here and just make this smaller so we can see more of the graph. All right. I'm going to draw the lines in blue. So the first line is relating to this over here. Right? Mark over here in red. Which means above the line, x equals 20. Other line solid above that line. X equals 20 is a vertical line through 20. It's 20 here. I'm going to draw a vertical line up here. Label the line with the x equal the equal sign, x equals 20. Put the arrow to the right. It means that the region I want is somewhere over here. Yeah, this one is y equals 15, above y equals 15. So this one is above y equals 15. Y equals 15 is a horizontal line passing through 15. This is 10, this is 20. 15 is right here between them. Horizontal line. This is y equals 15. I'm going above this line. So the region that we want is somewhere inside here now. We're not going to shade yet. We want to shade the final region. Then this line is x plus y equals 10. The less than means below. The y value is positive, so less than means below. So this one is below x plus y equals 60. Below x plus y equals 60. X plus y equals 60, as we said. Cross the y-axis at 60 up here. And cross the x-axis at 60 down here. All right, so it's going to go like this. Label the line with the equal sign. X plus y equals 60. And we're going below this line. So the region that we want now is somewhere in this triangle. We're not finished yet. We have one more line to put on, which is the line 2y equals x. Because I'm not working with this. X equals 2, x equals 2y, same as 2y equals x, right? This line, this one. All right, let me move this down here. So we're working with this one, which now means above, y is positive, so when above, the line 2y equals x, which is same as y equals half x. So that line is going to pass through the origin, as you know. Going to have a gradient of 2, 1 over 2. Right? So we can put another point if you want. You can put in an x value of say 40 or 60. For example, if the x value is 60, then the y value is 30. So half of 60 is 30. So it pass through 60, 30 right here. 60, 30 will be right here. All right? Pass through that. All right, so the line would go also through 2010. So it will go like so. All right, go like that. Move this line. I don't need this line right here. So this is a line 2y equals x, or y equals half x, this line. I have to go above that line, above this line. So the region that we want is inside here. So if I zoom it up, these are your vertices here, 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 and there. Those are your vertices. This is the region. Marking it out in red. That's the region that you want. So that's your boundary. I'm marking out in red. All right. And if you want to calculate maximum, you're going to have to go to these 2 points. Clearly, these two cannot give you maximum. Right? This one have a higher x and a higher y than this. And then this one has a higher y than all of them. So if you want to calculate the maximum, you have to test these 2 points. Now, what is this point? This point is clearly 2040 because on the line where x plus y equals 60 and the x value here is 20. This point is clearly 2040. And this point down here is where, what is it now? What is it? This point. Let's see if we can figure it out. It's on this line where 2y, where y equals half x. Y equals half the value of x. And then in addition to that, x plus y equals 60. It's y equals half x. It looks like 40-20 right here. 40-20. This point is 40-20. Because half of 40 is 20. And then when you add them, you get in 60. So those are the two vertices that will give you a maximum. All right, but let's see what the question they're asking. So that will be the graph, right? All right, that will be the graph on the shaded region, right? Did they say to shade? It said draw the lines of the graph associated with the four inequalities. Then it says 3 pockets are chosen at random. So we're going to mark those pockets now. Let's mark them over here. Let's mark them over here in black. Let's mark them in black. It says 3 pockets. Right here reading now. Make this smaller so you can see it. Zoom it up. All right. So here it says now 3 pockets are selected for inspection. It said their content are shown below. So pocket A has 20 X gold stars and 25 gold stars and 20 silver stars. So this means that A is a point 25, 25, 20. And then B now has 35 gold stars and 15 silver stars. So it means that B is a point 35, 15. And then C now is a point where we have 30 gold stars and 25 silver stars. So it means that C is a point 30, 25. And the question is saying, plot the points on the graph, A, B, and C. Plot them on the points and hence determine which of the 3 pockets satisfy the condition, satisfy all the conditions. So the pockets that fall inside this region or on any of the lines, the boundary lines, are good pockets. Anything outside the region, not good. Anything outside the region would not be good. So I'm going to erase the shading and leave just the boundary lines. So I'm working with that region in red. So I'm going to put the points in there. So the region that I want is bounded by these lines, these red lines. So anything that falls inside that region is good, or anything on these lines, good. All right, let's put them on in blue or in purple, the points. So the first point is 25, 20. So 25, 20 is right here. 25, 20 is right here. That's where A is. That's the point A. So A is a good start. So we can give A a tick. A is falls inside the region. Then B. B is 35, 15. 35, 15. So 35 is right here. And then 15 is on this line. Looks like right here now. Question is, what is this point? That point is on the line y equals 15 and also where y equals half x. Y equals 15. So this point is actually 30. This point is actually 30. This point right here, so this vertex, even though it don't look like it, it is 30, 15. This point vertex is 30, 15. This vertex. 30, 15. It's on the line where y equals 15. And it's on the line where y is equal to half the x value. So this point is 30, 15. But this point we're talking about now, 35, 15. If we're to mark it in purple, it will be right here on this line, 35, 15. That will be the point B. So we can tick A as a good point. We have to put an X on B because it's not inside the region. So I put an X on B. So B can work. B falls outside the region. And the last one now is 30, 25. 30, 25, 30 or so. So coming out to 30 and going up to 25. 25 is about right here. That's the point we're talking about. So it will be right here. Let me take off about the stick. 30, 25 is right there. So right here. That will be the point C. So A good, B good, no, C good, B not good. Right? So the answer is that C is also good. So the question says, and determine which pockets satisfy all the conditions. All the conditions are satisfied by, hold on. All the conditions are satisfied by pocket A and pocket C. B failed. B is outside the region. Are you okay with that? Very good?
Yes, sir.
All right. That is it for today, now, guys. We have done a good bit. Tomorrow's class, we're going on to matrices tomorrow on Monday. New topic. Starting the next phase of the program. Matrices, vectors, matrices, transformation, and vectors. That's the next phase of the program. Matrices, transformation, and vectors. Those are the next three topics we're doing. They are related. After that, we're going to go into trigonometry, trigonometry, circle theory. Trigonometry, circle theory, circular measures. Trigonometry includes Pythagoras' theorem on the right angle triangle and also non-right angle triangles using sine rule, cosine rule, application topic, elevation, depression, and bearings. Those will come after the next three topics of matrices, transformation, and vectors. All right? So and we intend to finish those three topics for the end of this year and actually start the first part of trigonometry. Trigonometry 1, the first part of trigonometry of right angle triangles. We intend to start that in December. And then the other parts of trigonometry in January. All right, so we're going to finish the matrices, transformation, and vectors, and the first part of trigonometry before the end of this year. Okay, guys, that is the plan. That's what we will do. All right, good. Okay, bye. Okay, guys, bye. Have a good day. I'm going to share the video in the group right after the class. Watch over the video and redo the questions, please.
Yes, sir.
Okay,
Alright,
sir.
Bye.
Okay, bye-bye, everybody.
Sir,
Yes?
I'm just telling you that I did my maths test last week, Friday, sir. And if when I pass it, I'm going to come and show you my paper.
Beautiful. All right, lovely.
Yes,
I like
sir.
that. All right, cool. All right, bye, everybody.